Welcome back, everyone. We're going to be looking at properties of tangents to a circle, and there's a few important key vocabulary things that I'm just going to review first off. The first thing I just want to review with you is the term called a radius. Now, a radius is from anywhere outside the circle to the center of the circle. If you have more than one radius, it's called a radii. So that means we could have another radius coming from this side to the center, over there from the other side, and they will be labeled AB, and then B being the center point and whatnot. Another important key term is called a tangent or a tangent line. Now, a tangent line is a line that runs along from one point to another and just barely touches the circle at the bottom. Where it touches the circle is called a point of tangency. The only reason the point of tangency is important because it leads to this, the tangent radius property. So according to this, it's a tangent to a circle that is perpendicular to the radius drawn to the point of the tangency. So you'll notice right here that they have a tangent line already on here, and it goes to the bottom and it just touches the bottom of the circle right there where it's a point of tangency. Then what they've done is they've drawn a radius from the middle right here where it touches the bottom of the circle, and they call that OP. So that forms a perpendicular line that intersects or cuts the line of tangency in half where it touches the bottom of the circle. Okay, so right here we have, so OP is perpendicular to line AB, and then there's angle OPA, which is OPA is equal to 90 degrees, and angle OPB is also equal to 90 degrees. So what this line of tangency does, and the perpendicular line you draw with the radius, forms two 90-degree angles on here. Now, moving down here to example number 1, where we would be able to find the measure of an angle in a triangle. You'll notice that line PB is part or half of a line of tangency or a tangent line. Okay. Now, we also know what they're asking here is we need to figure out this angle, but we know that where the radius intersects a line of tangent or the point of tangency creates 90 degrees. So in this equation here, we have two angles already because they're going to give us the 1 and they're going to give us the 90, and we have to figure out what angle X is here. And in this case here, we have 180 because all three angles in a triangle equally 180 degrees. And then we have 90 degrees subtract 50 degrees. So our line is 40 degrees. In the check example right down here, the same thing. So they're asking us to find what that angle is right there. And again, we know that this angle right here is equal to 90 degrees, right? So what they're asking here is they're trying to figure out what this is. So we're looking for angle OCD. We take the 90 degrees, we subtract the 65 degrees from 180, and we're going to discover that angle X right here is equal to 25 degrees. Okay, so just a few things there. There's a tangent line property, some vocabulary words, the tangent, the point of tangent, radius, more than one radius is called a radii. And when we draw that line of tangency, or the perpendicular line that cuts the tangent line in half, it creates two perpendicular angles or equal angles on either side.